Hello, class. This is the video solutions to Lab 3.1. One of the questions I like to ask on a test or a quiz will be graph identification, where I'll give you a few graphs and I'll ask you to match the graph with an equation. So when I look at graph A and graph B, I'll say, okay, match the graphs. Well, we know when we have a curve like this, I think this looks like an exponential function, right? It's not a linear function, right? We know this isn't y equals mx plus b because it's not a straight line. So we have something that kind of starts out slow and then increases over time kind of quickly, or decreases over time kind of quickly. We have exponential growth or exponential decay, right? So the graph that rises from left to right is growth, and the graph that falls from left to right is decay. And we know that in the equation y equals ab to the x, if b is between 0 and 1, we have decay. So what does that look like? Okay, so write the equation that governs exponential functions is y equals ab to the x. So if the b is greater than 1, we have growth. If b is between 0 and 1, we have decay. So remember, between 0 and 1, basically that's a fraction, like a half, a third, 3/4, etc. So we go back to our lab, and this 1/3 is clearly between 0 and 1, so I know this represents decay. So it's got to be matched with the graph that's falling left to right. Here my b is 3. So 3 is greater than 1, so we know that this represents growth, and that would be the graph that's rising from left to right. Okay. Question 2, also another type of problem I love to put on your exam. Most likely you'll see this on exam 2 and 3. If we look at the output pattern, you can see that basically there's two options. As the input increases by 1, right, that's the x, as this goes up by 1, if I subtract the same two numbers, right, if my differences are the same, I know that my function is linear. If I divide by the same number and get the same answer, for example, 25 divided by 5 is 5. 5 divided by 1 is 5. 1 divided by 1/5 is also 5. Right? So my successive ratios are the same. That indicates we have an exponential function. Also, you could say, well, for multiplying by the same number, right? 1/5 times 5 is 1. 1 times 5 is 5. 5 times 5 is 25. 25 times 5 is 125, right? We're multiplying by the same amount. We know we have an exponential function, okay? But I like to use this phrase, right? If the successive ratios are constant, meaning, remember, ratio is division. If I divide two numbers that are next to each other and get the same answer, that will be my growth factor if the number indeed is greater than 1, right? And if you look at the second example, when we subtract, right, if I were to subtract 16 minus 11, 11 minus 6, 6 minus 1, when I subtract, my successive differences are constant, okay? So this is linear, right? When I subtract the same two numbers, or two adjacent numbers, and I end up with the same answer, we have a linear function, okay? Also, you could say the average rate of change is constant, right? If we were to try y2 minus y1 over x2 minus x1. But just remember, your denominator is always going to be 1, because 3 minus 2 is 1, 2 minus 1 is 1, right? When we're increasing our input by 1, the denominator is always 1. So the project that you're going to see, we usually talk in terms of successive ratios, meaning division, or successive differences, meaning subtraction. And if we have successive differences that are constant, it's a linear function. If we have successive ratios that are constant, it is an exponential function. Okay, and if it's an exponential function, that ratio is your growth factor. If the difference is the same, that is the slope. The difference is the slope, right? So 16 minus 11 is 5, which is my slope, right? 25 divided by 5 is my growth factor. And I think that was it for this lab. Okay, so again, these two problems will definitely appear in your test, and these problems are pretty good, or will be helpful when you do your project. Thank you for watching.